Hello, I'm Jenny Grosslight, here to demonstrate how burst scans provide unique bus-level signal integrity insight. For bus-level signal integrity insight, there are two methods of scanning on the U4154A logic analyzer. The most commonly used method is the overlay mode. In this mode, we overlay each of the samples of the burst on top of each other after qualifying the read or write scan to only scan during valid bursts. As each eye is overlaid on top of the other, we end up with one composite eye, which represents the absolute best sample position for the logic analyzer to use in state mode measurements. It's also valuable when comparing all of the signals in the system to provide signal integrity insight of a qualitative nature. The second mode is signal trace mode or burst scan mode, and in this mode we overlay each of the samples on top of itself so that we build an eye that looks more like what you might see on a sampling scope. Here we see all 8 samples in the burst in sequence. This is the mode we will be covering in this video. Going into the Edit Current Measurement icon for an overlay scan, we can go to the Advanced tab and open up the trigger specifications. This is a specialty scan trigger that was made by the DDR setup assistant for you. But we can go in and change the samples from 8 to 1 so that we no longer overlay our scan eyes, but now do the burst scan mode. When we do this, we will get the resulting eye scan as shown. We see the actual preamble and back-to-back bursts, all of which were valid reads. Now we'll look at more specific triggers to capture very unique scans. For this particular scan, the trigger was set up to scan only if there were no back-to-back bursts. This gives us a view of all of the strobes relative to each other when they are coming out of tri-state, showing the preamble and then each edge of the burst. For this specialty scan, we set up the system to scan only when there was a read to rank 0 followed by 1 clock cycle of a no-op and then another read to the same rank. In other words, we set it up for a bubble burst scan. Here we see all strobes of our system scanned under the same conditions. We see on the left-hand side the first scan starting where it came either out of a back-to-back read or sometimes a preamble of tri-state into the read. We see all 8 samples of the first burst. Then we see the time where the no-op and the strobe was released. Some of the signals are floating up to the tri-state. On all signals, we see the time where the preamble before the second burst came in and began scanning. Bubble bursts can be problematic as it requires the termination to be released and then controlled again within 1 clock cycle. In the example shown, we are seeing the 3 last samples in a read burst, followed by 1 clock cycle where the data termination was released and tri-stated, and then another cycle where the next read burst to the same rank began. Note that the last sample in the first burst is collapsed. In this situation, the bus was being released too soon and was corrupting the last sample of the burst. This unique view was possible with the Agilent burst scan mode. Thank you for watching. For more tips, please view the entire video series, which can be found at www.agilent.com/find/U4154A.